So BioLayout, I'm not going to go through that. That's a very dull list. But it essentially, this tool has been in development for about over 10 years. It was started by this guy at the top, Anton Enright, down at when he was a PhD student down in the EBI, European Bioinformatics Institute in Cambridge. He basically had a problem in actually solving protein homologies, and so he thought about a way of building a tool to do it. And so he basically almost given up on BioLayout when I sort of proposed the idea that we should use networks as a means to look at gene expression data. And I ended up working in his lab for a year, developing the very first prototypes before I came to Cambridge. So the man below him is a guy called Stijn van Dongen, who's a mathematician. He is a kind of network guru. He developed the clustering algorithm that we use, just a general good guy to have on your team. Thanasis, some of you will know, who's here, who's the developer who took it in the first 3 years of development in Edinburgh, and then Tim and Derek, I guess more of you will know because they're more recent, and sadly they've now left us, although Tim is still living the dream with me down in Leith. But yeah, so we're at this point now where we've come a long way. I'm not going to go through all the features, but I think it might be worth spending a minute or two on benefits, especially in this commercial environment which I'm living in at the moment. You've got to talk about benefits, not features. Okay, so I'm not going to tell you what it does or how it does it, but I think it might be worth saying why it's good. So it's certainly one tool that you can use for many different types of data. It is actually fairly agnostic to what kind of data you put in there. It doesn't have to come from biology. It can be any kind of data. Certainly it's not platform dependent or species dependent or any of those things. It kind of loves big data. The bigger the data you put in, the happier it is. Better that kind of correlation works. I mean, there is a limit to that, but I'm hoping I'll demonstrate today it's a usable interface, usable by you guys. It's not, you don't need to know command line stuff, and it's all GUI driven. It's an immersive environment. I hope you'll enjoy getting immersed in your data and understanding what's there. And you can see large proportions of the data at a time. So obviously, when you're thinking about visualizations, a lot of those other visualizations, you kind of got to get it down to a few hundred things. If you look at a heat map, if you have more than a few hundred things, you can't see it. So actually, one of the nice things is you can actually look at tens of thousands of things. Very fast processing from data to analysis in seconds or minutes. We'll hopefully explore this. Integration of data, we can do that. And I think one of the most important things that I like about this tool is that when you approach a data set, you don't ask a question. So that when you ask a question of a data, you're immediately assuming that patients group A are different from patient group B, and you're putting them all together, let's say. That actually sometimes, what BioLayout will show you is what's in your data, not what question you're asking of your data. So it shows you everything, and it's for you to work out what's interesting, which is both a blessing and a curse because it doesn't give you that definitive answer that maybe a statistical approach might do. So it's kind of nice and satisfying. So you ask a question, and there's 122 genes which have been above the threshold, and that's your answer. It's kind of quite satisfying. This doesn't give you that, so that's a downside. But I would say you can fast and informed decision making. I can download a data and kind of get to know what it's about within about 20 minutes and decide whether I want to spend any more time with it. And that's really liberating. So we're going to go through all this, but basically it's a very fast from input to output. The visualization is obviously on one level an abstract view of your data. It doesn't mean anything in its own right, kind of. But actually it's this thing, the ability to get to genes underneath it and actually explore your data and understand why they are in this form, which is the important thing. You'll be spending some time looking at stuff like this, I hope, which is gene expression data. So just again to orientate you before we get in there, nodes represent genes or measurements. The edges, the correlations between them, the different colours that you're seeing are clustering, and we'll go into clustering as we get on. And it is, essentially a validated technique in terms of you can get it published, which is obviously, you can do funky things, but they're not publishable. There's enough background of publications now to know that you can work with large data sets, you can get them published, and reviewers are happy to accept the methodology. Okay, so just want to spend a minute or two on some of the basics, because if you're not really experienced with data, then you might not think about this stuff. And if you don't think about this stuff, then any subsequent analysis is going to be kind of on shaky ground.